have these two license file and the .exe file. So when you if you want to start to install your software, make sure you disconnect from your internet network and switch off your Windows security or any antivirus that you have. Because if you don't switch that off, you might not, you cannot run this particular .exe file, the execution files for the installer. So once you click the installer, it will request you to select the language. And then, of course, when you select the language, proceed with the installation. There is another dialog box where you have to tick to install, to create a folder. So once you select that, then you install the software. So this execution file will install, and finally when it's done, you can click run the software, or you can just click close. Because after that, the most important part in installation of the software is how to run that. Okay, so you have to install the license file. So here's how you do it. Once you have installed the package, you have to go to your Windows, okay, and you have to find your program files x86, okay. So you click that, you double click that, you will see there is a folder on GeoSlope. You click that again, and then you will see the GeoStudio 8. So you have to click that GeoStudio 8. You will see the bin folder. Click that bin folder, and finally you click that x64. Okay, so since you already have that execution file installed, you need to replace it. Okay, so I open another window. Okay, because I'm running the software, this computer will be slightly delayed. So you're going to copy this file and then you paste it here. Okay, once you have done that, then you go back to the GeoSlope folder and you create this licenses folder. So once you've created that licenses folder, double click it and copy this particular file, the license file, into this folder. All right. So once you have done that, then you can switch on the software. So you just click the icon. Okay. Let me switch this back off. Okay. So when you click the icon here, it will execute the software. All right. So when you execute it for the first time, you will see this in blue, and then suddenly it turns to gray. That means you don't have the full license. So how do you want to acquire this software to connect to the license? You go to your software there, you go to the help tab, and then find the license management over there. And then the first time that they will select is the available license. So you go to the second tab, giving you the local settings, okay, and then you browse. Okay, unfortunately, I cannot browse this because it's already um, it has already selected the licenses. So you click the browse, there will be another dialog box that will show you where do you want to select the file. So you go to the where that particular dialog box, you go to this folders, program files, 1986 slash JuSlope slash licenses. So this folder you have just created from that particular process. So find that folder and then you just apply. So once you apply that, click OK, then the gray color will turn to purple. So once it's there, then you can select any of the modules to run your analysis. Is that okay, ladies and gentlemen? All right. Okay. So once you have opened the software, okay, you have executed the software, this is the interface that you're going to see. You have the file here, edit, file tab, edit tab, view tab, window tab, and help. And then over here, you have all the modules: Slope W, Sit W, Sigma W, Quick W, Temp W, Citran W, Air W, and Redos W. Now, initially, JustStudio developed only Slope W, which is to run the stability analysis. Okay, so as it moves further in 2007, they've created a few modules, creating the SIP W, looking into the permeability of the soil, okay, how the water flows in the slope. And then they have Sigma W, which is used to analyze the deformation of the ground, okay, for construction. So this one will relate more onto the compression characteristic, okay, compression properties of the soil. And then you have Quick W, which runs the dynamic analysis. And then you have the Temp W, okay, for temperature analysis. Citran is actually the contamination transport module, which runs the contamination of the ground. And then you have Air W, which further looks into the environment in the ground, the suction. And then you have Vados W, which looks into most of the permeability functions, right? So today we are going to run Slope W so that you are you will familiarize with doing the analysis. So once you click this, okay, mine is slightly slow, right? It will actually create pop up this dialog box. Okay, so this dialog box is where you have the Slope W analysis, and then you have you can add whatever analysis that you want here, okay, on the tab here. Okay, you just add that, and then you can see what sort of analysis there that you can add into the slope W analysis. But for now, we're going to do only slope W. So you have all these settings here, all the tabs here, settings, slip surface, and then factor of safety distribution and advanced, right? Now, do not play around with this numerical procedures, because these numerical procedures, if you are an expert user, you seem to want to increase your number of slides, you can do that. You want to have a minimum slip surface depth, you can do that. You want a maximum number of iterations, you can change that. Sometimes when you run analysis, it takes a longer time, so you need to reduce the number of iterations. And then your total difference in the factor of safety. Okay, so this is the numerical procedure that you need not touch or change. This is the factor of safety distribution. So you can look at the most of the time the users will click constant, but if you are expert user, you might want to use the Monte Carlo trials. It will run up to 2,000 iterations. And if you are not familiar with that, then you use spatial variation. Okay, and then you can also click on the set sensitivity parameters. So you click that, then you will see the sensitivity parameters, which you will look into some of the mean, range, and whatnot. So my recommendation is you don't need to use this tab, just follow on the constant, right? Now, when you go to the settings, here you have the side function. You can run for the half sine function, the constant function, clip sine function, trapezoidal function, and fully specified function. So as a novice user, or I would say basic modeling, okay, for new user, you just click whatever default that has been selected by the program or the software. But for the poor water pressure conditions, okay, there are a few selections that you can run too. You can have a parent analysis, okay, when you have previous analysis, other GeoStudio analysis. This is a poor pressure RU, okay. Not many notice this, but if you are an expert user, sometimes you don't want to deal with the calculation of poor water pressures, so you are going to use RU for the slice, and you will have similar RUs, okay, poor pressure ratios for each of the slices, right? And then you have the B bar, right? Piezometric line with RU, piezometric line with B bar, and pressure head spatial function. Okay. This B bar is actually Skempton B value, right? Which looks into the saturation, and if it's partial saturation, then you use the different Skempton B value less than 0.95, which that one is more technical lah, right? So when you want to run your analysis, you just click the piezometric line. So when you click the piezometric line, okay, it will ask you to select whether you want to apply the phreatic correction or you want to use the stage rapid drawdown analysis based on Duncan et al. 1990. Now, if you are unfamiliar with that, you just click the apply phreatic correction. So it will apply the water phreatic level, and it will basically do some correction when you run your analysis. And then you have the pseudostatic analysis. You can run the undrained strength, or you can run just effective stress strengths, but you just click none. And then you get the partial factors. Usually you have to put in based on standard code of practice. Either you use JKL specification, or you use BS, or you use MS. Okay, but for now, for stability analysis, we use Eurocode and JKL specification. You also have the Geo Hong Kong specification. Okay, so once you have clicked that, you have selected the piezometric line, Then you go to the slip surface. Now, for the slip surface, there are so many information that you want to do from here that you need to select. Now, if you are running your slope from the uphill to downhill is from left to right, then you click left to right. But if you are using if you are designing a slope, uphill is on the right, downhill is on the left, then you select right to left. Now you notice most of your notes examples are given from right to left. So we will do right to left to see how it actually runs. Okay. And then you have that slip surface option. So you can have number of critical slip surface to store. Okay, most of the time it's one. You can select even maximum of 40, 50, but usually we pick just one. Okay. And then you can use the entry exit, or you can specify the radius tangent lines with the specified radius tangent line, or you can use the grid and radius method, or you can use the block satisfied method, fully specified, and critical slip surface usually from another analysis. Okay. So for a start, we're going to use the entry and exit, and this entry exit is whereby they give you few assumptions or trial slip circles. In the lecture that we provided to you, we only provide you with one point of origin and radius to determine the slip circle. Whereas in the process of an analysis, if you want to determine the factor of safety, you have to run a few trial slips. Now, for slope W, it will actually calculate for you almost 100 trial slips. Okay, what are they? I will show you later on. And then from there, you have the tension crack option. If you want to run a tension crack with angle, then you can put that. If it's just a tension crack line, okay, that's just a line, a vertical line. And then you can put the depth of that tension crack filled with water, or if it's just dry. Okay. Now, once you select that, okay, we're going to do from right to left. Okay, so we're going to close that, and you have this workspace. And this workspace, you have all these grids. Okay. So, are you okay for now? Any questions?
Yes, sir.
All right. Okay. Right. So once you have done that, now, first, what you need to do is, okay, you have all this stats here. File, edit, set, view, key in, draw, sketch, modify, window, and then you have all these icons. Okay. This is to redraw. This is to sketch your polylines, sketch lines, sketch rows, double rows, circles, okay, arcs, and then you want to change the color of your lines. Okay, this one is most important. This is the axis. Okay, later I'll show you how to generate this. And then you have the sketch dimension, pictures, sketch text, and then down here is where most of the icons are going to be used. Okay, this one is to modify objects. Once you have drawn the object, you need to modify, so you have to click that. This one is the view information, view report. This is you are going to draw the regions. You want to split regions, and then merge regions, draw points, draw materials. Okay, draw materials, that means you key in your soil properties, and then you want to draw the entry and exit slip surface. All right, and then draw the slip surface axis, and then subsurface limits, and then you want to draw this, the pore water phreatic line, and then draw point loads, draw reinforcements, surcharge load, and then contours, and then finally look into the contour labels, right? So for the first time, you have to select or you have to create your page dimension. Now, the page dimension is important because you want to draw your um, display and you want to print. Now, in this set page, now you see this in inches. Okay, so you convert that to millimeters. Now, you have to memorize the page dimension. Like, for example, if it's an A4, you have 297 and the height is 210. Okay, so this would be landscape. So you have that dimension. Now, for an A4, it's 297. If it's landscape dimension, 297 times 210. If it says A3, it's 297 times 420. Okay, and then if it is A2, you have 297 multiplied by 2, which is, wait, see, 594 times 420. And then if you want an A1, it should be 594 times 840. So these are the page dimensions that you have to familiarize in the drawing. If you are, in the first year, you are given, you have enrolled in AutoCAD, okay, a lecture on drawings. They should give you this basic information. So once you have that, then you have to set your units and scale. Okay. So we are going to use metric values. All the units will be meters, kilonewtons, pressure will be in kilopascal, strength will be in kilopascal, and then your unit weight will be 9.807. Okay, this is standard values given to you. So your scale here, it will start 1 to 200, and you notice that when you have 1 is to 200, the maximum image that you're going to display is up to 54.4 meters. Okay, you have to deduct by -5 because you have to draw the axis. And then this is on the x direction, whereas in the y direction, which is the verticality of the slope, okay, the maximum you can go is up to 37 meters. So if you want further dimension, if your slope say it's more than 50 meters, so you have to increase your scale. So you will have a slope of almost 100 meters long, okay, on the cross section. And then if you want the vertical exaggeration, then you maintain 200. If you want the normal scale, then you also type with 400, so you can have a slope of more than 60 meters, okay, or slope up to 79 meters height, right? This one a maximum of about 113.8 meters, so you can have, say, 60 meter slope, right? Okay, but most of the time, if the slope is small scale, we just take 200 over 200, right? So you can only generate up to 50 meter slope and a height of up to about 35 meters. So you apply that and you click OK. Okay, nothing is displayed, right? Okay. So you need to check the grids. Okay, your grid is 1-to-1 spacing. Okay, so you snap the grid. If you don't snap the grid, then your diagram would be irregular. You can also do that, no problem. Okay, if you display the grid, you will see the points here every 1 meter. If not, then you don't see the points. Right? So usually I like to look at the grids because I want to draw that. Okay. Now, before I forget, are we doing it from left to right or right to left? Okay, so from right to left, yeah? Okay. So from right to left, if you want to sketch your axis, okay, this will actually display elevation on the left and your distance at the bottom. Here, if you select this, it will display your distance at the top, your elevation at the bottom. Okay, so you have a minimum axis 0. Maximum just now is about 50 meters, so you have 50 meters here. And the y-axis, you have 30 meters, so you have 30 meters here. So you get that particular axis, right? So since you're doing it from right to left, so it's best that this particular axis is at the bottom. So we just select the one in the bottom here, and then you type that distance. Okay, so it will display the grid. Okay, starting from 0 here, 50 meter here, right? Okay. Now you close that, right? Everyone is okay so far? All right. Now, how do you want to get all this dimension here? First, you have to sketch in your paper. You have to look at the dimension of the slope, and then you have to see what are the coordinates that will specify you to draw the slope. So you have to check that. Okay, for example, your project here. So yours is Chainage 259, is it? 298. Oh, wait. There we go. Okay. So you have that chainage. If I'm not mistaken, it's not this. It's borehole, I think borehole 16. Ah, okay. This is supposedly your layout plan. Uh, okay. So I'm sure this would be your diagram. Okay. So this is your slope. I only require you to generate only this part because this is the existing tower here is approximately 50 meters away from the, this is 20, this is 60, yeah, 40 meters away from the slope. So we want to look at this stability construction, whether it affects this particular pylon, okay, can be a tower. So I want basically to know the stability here. So I run this as right to left. Okay. So I sketch the dimension as given from the drawing. Okay. So you have to come out with this dimension, right? and that is the result for the stability. Okay, right. Okay, this is just your particular project, so you want to run that. How do you want to draw this? So here is where I'm going to explain to you. So once you get all the profile, first of all, you draw your polyline. Okay, so you can draw your slope based on the dimension given. Okay, so you draw that line, click here. Okay, on the left button, and then if you want to remove just now the line, you just click the right button, then it will undisplay the line. So this is your, let's say, your slope profile. Okay, then you have to look at your borehole and you have to create the soil profile like this one here. So you have to create the soil profile, okay, based on that borehole. How do you want to do that? You just use the same polyline method, and then you just draw the profile. Okay, so you see how I want to hide this line. I just right button click that, and then it's gone. Okay, so then you have that profile, soil profile, nicely drawn. Okay, all right for now. Okay, right. So then you want to draw the regions. So there is an icon here which shows you draw regions. So you select this, okay, and then you just follow the regions as you draw the polylines. See, so you have to make sure when you draw this, it follows your polyline. So the purpose of having that polyline is to control your drawing dimensions, to ensure that you get your profile and the slope fully covered. Yeah. So as you draw the region, make sure you close this region. Okay, either you do it in a clockwise direction or in the counterclockwise direction. For this purpose, I use the counterclockwise direction. So that is the first region. You want to go for the next region, you just draw the next region, following the points that you see there. And then you close the regions. Okay? All right. So once you're done, you just click escape, and then it will give you the profile. Okay, so far?
Doctor.
All right. So what you want to do next? You want to key in the regions. Okay, so when you select that icon, you click that, you have that key in. And this is where you include your soil properties. And if you have structure, you include all your structure in that particular region. So you click add here, and it will add a new material here. So you click the new material, you change the material. Say this is your soil, so you put soil 1. If it's say sandy silt, okay, you put sandy silt. And if it's sandy clay, you put sandy clay. If it's sandy clay lah, based on the profile. And then if it's silty sand, you put silty sand. All right. But if it's say sandy silt with different strength of layers, then you might want to put Sanisil 1 or Sanisil upper layer and then Sanisil bottom layer. Okay. Right. This one I put Sanisil 1, for example. Then you click, look at the material model. Okay. Over here, you have a lot of material models that you can select from. You can go for molecular model, undrained shear strength, high strength, which is rock. You can have just bedrock, impenetrable, assuming that the bedrock is intact. And then you have bilinear, you have depth function, you have datum, and then anisotropic strength. This one is for rock also, and then shear, normal function, anisotropic function, combined function, and whatnot. So if you want to go further as a hardcore user for slope W, then you can study this on your own. But for now, as a novice user, a first-time user, you just select molecular. So in the molecular, you have all these steps: basic, suction, envelope, our envelope, okay, from Duncan and all, and then liquefaction, and then advanced. Okay. This one later I will show you why you want to use saturated unit weight or use constant unsaturated unit weight. This is where if you run your stability analysis for partially saturated soil. But for now, you go only on basic. So you have unit weight, you have cohesion, you have friction angle. Now, mind you, the properties you're going to use here will be the effective shear strength parameters, C prime and Phi prime. Okay. If you were to use the undrained shear strength, that is CU or SU. SU is the field undrained shear strength. CU is the laboratory shear strength. Definitely they are before ESA, effective stress analysis. So the unit weight is from the soil properties. Most of the time, okay, on slopes, definitely your unit weight is more than 16 or 7 because most of these slopes, they are over consolidated. Okay, most of them are over consolidated, so you will have direct cohesion. Some of the slopes, when they are, if they are field embankment slopes, you might have apparent cohesion of 0, depending on how it is being compacted. So this one is covered in soil mechanics. Okay, so we're going to take a value, say about 17 kiloliter per cubic meter, right? That is the unit weight. And then, okay, as most of the practitioners, they will use the apparent cohesion value between 5 to 10 kPa, not more than that. But for me, in the design consideration, I always use, if it is at a high friction angle, over consolidated, we're going to take this as 5 as a max. If it is moderate strength, okay, from firm or medium dense, okay, we're going to take roughly between 3 kPa. And then if it is soft or loose, I would take usually between 0 to 1 kPa. For now, we'll just put a value of 3 kPa here. Okay, and then assuming that the slope is over consolidated, the friction angle, there is actually an empirical value to determine the angle of dilation. Okay, angle of dilation from the friction angle. Usually we take the friction angle of peak minus ultimate, so you get the angle of dilation. But if it says empirical, which is you are unsure, if you have a friction angle of more than 30, then you will have dilation angle. because the equation would be for dilation angle is friction angle minus 30 degrees. Now, say if this is 33 degrees, that means you have a dilation angle of 3 degrees, but it's not being incorporated here. Okay, you will have that is the shear strength, the effective shear strength parameter of soil. Okay. Suction is whereby you want to look at the changes in suction due to saturation. But in this case, I think you can ignore this for further analysis, unless or otherwise in the class you are being introduced to partially saturated soil. So in a partially saturated soil, you have 3 axes. You have the shear strength axis in the y direction. You have the net stress axis on the x direction, and then you have the suction, metric suction axis on the z direction. So there is also a function where the changes in the volume water content due to suction. So I would not go with that into detail, but you can put in a friction angle for suction. Usually it is less than the friction angle for net stress. Okay? If you have here 33, so you might have a phi b of less than 30. Okay? That is usually that is the theoretical value. But for now, we just put that 0. Okay, so you have that, and you can change this color. Right, you can change this color, so you can have any color that you want. Okay? It suits you. I will take this, and then once you've done that, so you can basically use this, and then you have that, and you can just assign that. Okay, just click at that region, and you will assign the soil properties. So you want to include more soil, you just click the add tab here, generate new material. Again, probably send the silt to, and then use the molecular model. Okay, it's now 17. Probably you want this to be unit weight. Of course, it's sometimes higher than the top one. Usually, it's because of the overburden pressure. So you say that 18. Okay. Of course, you have to look at the borehole records and the laboratory tests that I've provided to you. And then the parent cohesion, say just now, I will take 4, and then friction angle of 35. Okay, and then I will set the color. Say I want it yellow. Right, so I have yellow there. Okay, and close that, and I just select the region. Then it will give me the 2 layers. Right? As simple as that. Okay. Are you guys okay?
Yes, sir.
All right. Okay. So once you are done with that, you can also include loadings. Okay. You can add here what is the loading that you want to draw. Say you can have traffic loading, you have building loads. Okay. Let's say we have a traffic load at the bottom here of 20 kilonewton per meter square. Okay, then you draw that. Okay, make sure draw for 1 meter. Then you write button click. Okay. So that is the traffic loading. Okay. And you can also draw another one. Okay, that is line 1. You want to have building loads here. So you can add one more. Okay, building loads of say 10. Okay, then you draw that. Okay, put there. Okay, hold on. Okay, saya kurang. Tak boleh lah, saya ada training je. Nanti saya tahu. Okay. So once you are done with that, okay, you click. And you can also draw your reinforcement loads, right? You can draw your reinforcement loads, but I would not draw that at the moment. Just want to inspect the slope, right? Okay, then you can draw your phreatic line. You select that phreatic line. Okay, just add that. Okay, you want to draw the phreatic line. So refer to the SI report if it's given to you. So if it's not, then you just draw looking like that. So that is the presumed seepage regime, okay, in the slope. That is the phreatic line. That is the seepage regime in the slope. Okay, once you have done that, then you click done. So you have your beautifully drawn slope here. Okay. Now, how do you want to run the analysis? You have to put in the entry and exit slip surface. So you click that, and then you just draw your slip entry first. So you click the entry, don't release the button, you just click there and then you extend it, okay, just to get where the slip circle is going to be generated. And once you have done that, so that is the entry position of the slip. And for the exit, okay, you make sure you do the same process. You click that, don't release the button, you extend it, and then once you have selected to where you want the exit slip surface to be, then you release your button. Then that is where you have the entry and exit points. Okay, once you have done that, click done. Okay, now what's next? You have done all the slope. Now you can actually check whether there are errors in your drawing. So you can just click start here, solve the check analysis. Okay, there's a start button there. And okay, you need to save this. Where? Oh, this is in Texas version 20, exercise 4. Okay, so I just say find a folder, any folder. Probably you create a folder for your project, and then you click there, slope stability trial. You can name whatever you want, or you can name based on chainage, and then location. Okay? It suits as you suit, as you are comfortable with. All right. Okay, so it starts to analyze. Okay, since there is no error, you will run the analysis. So once you get that, okay, it will give you the minimum failure, minimum subcircle, and what is the factor of safety. Now, in this case, the minimum factor of safety is 1.675. Okay, so you can have a lot of the slip circles. You just select that, and it will give you a different slip circle. You can go for deep seated as well. This is shallow. You can go for deep seated, right? Of course, the factor of safety is 1.8 to 8. So what you see here, these are a few of the trials of the slip circle, right? Okay, goes down to almost 121. I don't see more than that. Okay. Oh yeah, I think your minimum is 122. Okay, so 122 trial slips, and they get the minimum slip circle 1.6 final trial, which is 122. So you can have a look at all of these different slip circles. And this is where um, engineers can play around with the stability. Usually, when they get they want to design the slope, they want it to be safe, they will just select the safest slip circle, which is not more than 2. Usually, when I design my slope, I want to make sure it is safe, robust, and economical. So my factor of safety would not be more than 2. It will be between 1.5 to 2. Okay, if I design it more than 2, then I will re-adjust the slope design to make sure the cost would be less to construct, and then it is safer between 1.5 to 2. This is my let's say my rule of thumb in the design. Okay. Okay. So you get that. That there is the minimum slip circle. You can also have slip circle contour maps. All right. Show legend here. And you have that slip circle contour maps over here. And you can select the slip surface. Okay. You can plot the graph, factor of safety. Right. This one, factor safety versus lambda, I think it's not of use for you. Okay. Then you can draw contours for the pressure. Okay. Then you can add more, probably new contour, material properties, or you want pressure head. Okay. And then you select close, so it will give you pressure head. If you do not want that, you can delete it. Okay. If you don't want that, then you just look into materials. You want contour labels, you can label that. Okay. None, you don't have the solve properties. You want to solve properties, you have to select here. Okay, that is the contour. That is the material color. Okay, so all this icon here, they have you want view preference and fonts. You click that. Okay, how big you want your factor safety fonts to be? That one is small, so you can enlarge that to say 15, 16. Okay, access dimension, you can enlarge that as well. Say 12. Contour labels, node labels, point labels. Okay. And then view current slip. So you can actually change whatever dimensions or information from that. So you click that, and you click close. Then you have an enlargement of your fonts there, right? Then you can view regions. Okay, display material. Okay, you want to display that sunny silk. Okay, view mesh if you require. If not, you don't have to. Okay, and then forward the pressure conditions. Okay, reinforcement. So you unselect this, and then it won't be there. Okay, picture. Picture. All right. Now there's a thing that sometimes you need the information to be displayed, soil properties and whatnot. So usually I will sketch text here, and then I would insert the fields, right? Now, if you are using Joe Studio version 2020, it would actually give you table of the properties, whereas here it will give you like just details. So what you want there? Name, model, unit weight, cohesion, T. Okay, I don't have the 5D here. Yeah, isometric line or materials. Okay, just that, and then show new properties. Input units, input labels. So I want to insert that. I just click here. So then I have the soil properties. Okay. How to display that again? You click here, insert field. So you have this, right? And then you insert that field. This dialog box will come display, and then you have what are the properties that you want the software to display. And then you click that, and then you just click insert, and then this would be the display. Now, of course, if you look at that, oh, it's awkward to have all this write up of the properties up here, right? So we're going to modify it. We're going to move it to. I click the modify object icon here. Have this dialog box, so I just move it to where I want it to be placed. So I want it nicely placed below the legend, and then I have it there. If it's not nice, not beautiful enough, put it there. Okay, you can also change this legend display, put it at the center like that, so it would look nice in your report. Okay, and then done. So then you can copy this particular copy all there, and then you can paste it in your report. Okay. So that's it for drawing the slope from right to left. Okay, any questions? It's quite easy to use, right? Easy to maneuver the software. So if you want to run the stability analysis, you can do this. You can use the software. Okay. Are there anything that you guys want to add? So lepas ni dah boleh start lah buat projek kan?
Boleh,
Doctor, I have a
Doktor.
question.
Yeah.
So is there any method to like make it match with the match in the PDF using coordinate or something?
Yeah, you okay. You can draw using the coordinates, but most of the time the engineers will draw that in AutoCAD, and then you can actually import the drawing. Okay, this one you export. Uh, Actually, you can import the drawing, and then you can transfer that here using from AutoCAD. This one you export. You can actually import the drawing. Unfortunately, there is no supposedly have that particular um, tool. Okay,
Okay, doctor, understood. Thank you.
yeah, you can actually draw that in the AutoCAD for the XY. But from there, then only you can import the drawing into SlopW. But most of the time, what I do is that I get the coordinates, and then I just transfer that in a paper, and then I draw that one by one. It takes time, but it's much. I mean, you are very careful with your slope when you draw that. Okay? This example is just to show you how to run analysis. Kebetulan dapat je factor safety more than 1.5. Okay, so the slope ni for engineered slope, you need 1.5, but for a natural slope is only 1.3. So this one being natural 1.3 with 1.675 ni dah memang definitely safe lah. Okay. Okay. Like this one 1.637. Okay, this is actually your project line. Jadi saya tunjuk macam ni je lah. Then saya tutup yang ni. I also run infiltration modeling. So when we run infiltration modeling, we want to look at how water infiltrates, causing instability to the slope. We find folder. Actually, it's here. Okay. This is one of my exercise with master students. So this slope is from left to right. Okay, and then I have that entry and exit. We have buildings here, and then we do infiltration modeling. So you can see the factor of safety here is less than 1. So basically, when the water seeps into the slope down to 8 meters, then it triggers failure. Okay, this is for 8 meters. If you look at 6 meters, okay, so actually you can run like this, or you have to run SIP-W. So SIP-W, you have to include the region where infiltrates into the slope. See, at 6 meters, the slope is still safe. Infiltration at 6 meters is still safe. It's more than 1.5, in fact. But when it goes down to 8 meters, like this, the factor of safety goes reduced significantly down to less than 1. So we know that 8-meter infiltration will cause the slope to fail. All right. So how you do this? You increase the unit weight of the soil from bulk unit weight to saturated unit weight. This principle of increase the unit reducer where this slip circle. Initially, you have apparent cohesion of C. When it becomes saturated, we assume that suction diminishes and then C prime becomes almost zero. So we put a zero value there. So you only have the resisting factor of friction angle. So that friction will resist the additional weight from your slope, from your soil. So that is where the factor of safety reduces. Right? So this is based on the FOS is equals to the resisting moment, okay, divided by the disturbing moment. All right. So that is one example. You want to look at other examples. Okay. This one is a slope that I analyzed. I also look into 1 meter infiltration just to see what will be the factor of safety for the slope. Okay, that is the cross-sectional area. That is a bungalow. Okay. Oh, see, there's a lot of grids. Okay. But when I run the analysis, the grid is gone. If I want to modify, I can modify this. Put it here. Okay. Then you can see the dimension of the RC wall. Okay. And you can see factor 60 is 1.667 for 1 meter infiltration, which is still safe. The wall doesn't move. Right? Then, of course, we put the groundwater level like this because supposedly there is a horizontal drain here that will lower down intercept the groundwater table. Okay, this one is due to infiltration. Oh, dah banyak sangat. Kita tutup. Okay. Okay. So this one is with the infiltration juga. And this is without the infiltration. So you have a global stability of 2.148. So the retaining wall is giving a higher factor of safety. Yeah? Yeah, of course, the factor of safety for the retaining wall against moment rotation, sliding, bearing capacity is also to be checked lah. That one is designed by the consultant. So consultant design gives me dimension, they provided me with the dimension, then I just check for the global stability, right? So it must follow the design criteria as set by JKR. To be safe, use JKR specification. Okay. Yeah.
Saya try download Juice Studio ni. Tapi bila nak run kan ada part yang kena tukar license kan, yang kena browse apa semua dekat license manager tu kan. Saya tak boleh nak run juga, dia jadi kelabu.
Jadi kelabu.
Maksud tu macam
Okay. Masa you install, you tutup tak semua? Internet
saya tutup.
Internet tutup. Apa ni? By antivirus you switch off.
Saya tutup firewall, semua saya tutup.
Okay. Then you install following the step tadi lah yang saya tunjuk.
Saya ikut dah step doktor tu. Macam 3-4 kali ke saya uninstall, tapi still tak boleh nak run dekat license manager, macam sangkut dekat license manager tu.
Okay, masa license manager tu you select tak license yang folder you buat tu?
Select.
Okay, you masuk tak the LIC file tu dalam tu?
Masukkan.
Okay. You masukkan the first step yang license yang ada .exe file tu, you copy paste balik tak dalam XCC folder?
Yang kan asal dia kalau kita download tu kan ada license kan. Saya copy, lepas tu saya masuk dalam folder yang saya buatkan tu.
Itu saja kan? Yang bin ni you tak buat?
Yang apa?
Yang dekat sini. See. Juice Studio 8 ni bin XCC4 kan? Nampak tak? Yang ni memang dah ada.
Yang tu.
So you kena
yang tu saya dah replace gak dah.
Dah replace juga? Okay. Komputer you version apa? The latest ke ataupun dah lama?
Tak adalah latest mana. Dia macam time 2022, 23 macam tu.
Okay. So mungkin ada software yang menghalang you untuk buka crack version. Takut dia ada spamware ke, ada malware punya protection kan. So kena tengok komputer tu.
Macam try dekat komputer lain lah ni.
Kalau try komputer lain, rasa orang lain ada masalah yang sama ke? Dia tanya. Like myself, saya ada 2 komputer, dua-dua okey. In fact, yang you beli 2023 tu saya pun ada ni komputer saya beli 2023 HP. Saya install okey je. So, mungkin you punya komputer lah tu sama ada tak compatible ke, RAM tak cukup ke, memory you berapa?
Alamak, sekejap. Saya cek. Storage. Doktor nak tahu storage ke RAM
Storage dulu. RAM berapa?
Storage 477 GB.
So 500 GB lah. Should be okay. You punya RAM 8. Okay, patutnya tak ada masalah. Kena check lah tu. Kalau tak you pergi, you kena datang jumpa saya, kita tengok macam mana.
Boleh. Nanti saya WhatsApp doktor.
Alright. Okay.
Alright, thank you doktor.
Alright, welcome. Okey, tadi saya save ni kat mana pun saya tak ingat ya. Course note, Plexus Vision 20, exercise 4. Okey dah, betul dah tu.
Doktor, dekat chat, sorry mengganggu, dekat chat box tu ada student tanya, boleh
Oh.
ke kalau guna student version je?
Student version ni dia ada limitation. You cannot do more than 2 soil layers. You boleh buat sampai 2 material model je. Yang ketiga tu, lepas tu dia keluar error, dia kata you require full license, full version. Ada lagi kat chat box. Ada. Okey, Nurul Ain saya rasa dah jawab tu. So you nak guna student version, satu you boleh view saja, satu lagi maximum of 2 material models. You cannot go more than 3. Kalau full version, you can do a lot of things. You can even put design reinforcement semua. Okay. This one is another project yang saya baru siap. Construction pun baru siap. Saya tunjuk dekat klien kenapa dia punya retaining wall tu collapse. Okay, this is the slope dekat ulu tiram tu. And then kita buat infiltration down to 4 meters. So dia punya sepatutnya factor safety dia kena more than 1.5, tapi dia dah reduce to 1.3. Bila reduce to 1.3, dia punya wall ni bulging. Okay. Tahu gambar ada tak? This is the wall lah. Dia dah bulging. So kita letak bukan kita lah. Masa wall tu dah bulging, diorang letak this counter berm dengan gravel lah. Okay, nampak ni creep wall ni dia dah bulging tau. So nak mengelakkan dia bulging excessively, so dia orang letak counter berm lah. Dia pakai gravel size. Okay. So masa tengok mula-mula gambar dia, ada dia punya report ni, ni report dia gambar Sorry lah, komputer saya ni slow sikit. So ini creep wall dia. Ini yang masa dah siap mula-mula. Cantik wall dia. Okay. Creep wall completion in September 2020. Okay. This is the creep wall. It's very nicely constructed. Okay. Nampak cantik. Surface ni ada green. Okay lah. Right. Tapi January 2024, because they didn't do the maintenance, dah ada overgrown shrub, lepas tu air pun masuk dalam, wall ni dah bulging. Okay. And then slope ni pun dah bergerak. Dia dah settle about 1 meter, and then the slope has moved forward in approximately 1 to 1.5 meter. So for that time being, diorang letak tarpaulin sheet lah, tarpaulin sheet, cover the slope, and then dia letak the apa ni, kita panggil ni the counter berm ni lah. Tapi if you notice that masih ada air keluar kat tu. Maknanya dalam belakang wall ni ada air. Okay. So this was in 2024. Okay. So this photo was taken last December 2025. Wall dah siap. Okay. Ini wall. Tengok, ni saya. Okay. Itu wall dia. Dah siap, cantik. So pump sebelah sini pun dah boleh guna balik. Asal dia tutup. Okay. Slope tu habis dah jadi konkrit. Dia tak nak air dah masuk dalam slope tu. So kita granite saja dia punya surface. And then kita buat drainage lah. And then ada lagi apa ni, horizontal drain. Kita design. This is the slope daripada tepi. So ada cascaded drain. Ini creep wall yang bergerak tu. Bila kita remove, dia cantik pula, dia curve macam ni. Kita okey lah, dah curve macam ni. And then kita granite, kita shotcrete ni, so dia jadi granite surface. And then sini dia jadi, this is the granular material yang daripada counter berm tu. Dah ambil balik, kita compact belakang wall ni. Wall ni is actually keystone tieback dengan jogrit. Okay. That is the fine. Dia ada. This one, the drainage system was designed by Dr. Jurina lah. Tadi nampak Dr. Jurina kau saya tu kan. So she did the design for the drainage system. Dalam slope ni, most important, first things first, keluarkan air. That means you must have proper drainage, okay, on the slope. Right? I think this one will be covered in your lecture lah. So when you have the water flows freely on the surface and into the drains, then your slope will be safe lah. That is the first thing that you will have to cover, take into consideration. And then tadi yang dah settle tu, kita buat granite. Then atas ni, kat kawasan rumah ni, dah cantik dia punya platform. Tak ada dah crack-crack. Okay. So, this is dia punya stability analysis. You nampak tu depan je, you tak nampak apa yang kat dalam dia. Kat belakang dia, inilah dia. Ada keystone, ada geogrid, ada sheet pile lagi. Memang slope tu stable lah. Kalau kita tak protect the existing slope ni dengan sheet pile dekat sini, then ada besar kemungkinan slope ni bergerak lagi. Kita tak boleh sheet pile sini and then kita biarkan repair balik quick wall ni dah pre-failure. So kita tanam quick wall. Kalau tidak, you guna balik sini, you reconstruct, dia fail lagi, then tak guna dah ada sheet pile ni. Okay. So countermeasures of design tu you kena tengok. Nampak macam mahal cost ni sebenarnya tak mahal. Slope ni tinggi 15 meter, panjang 30 meter, buat tadi semua tu will cost about 2.2 million. Okay. Hard comment ni saya ada buat analysis lagi tak tahu. Right. So surface ni kita letak shotcrete lah. Okay. Alright, I think that's it. Kalau you tak ada soalan lagi, I pass baton balik kepada Madam Farah Fifi lah. Okay, Madam Farah.
Okay, thank you, Dr. Isma. No more question from students? Dah habis dah sesi Q&A. Any more question? If possible, we can still have another one question. Ada lagi ke?
Masa banyak lagi, tak apa. Nak tanya.
Masa banyak lagi, ada baru 11.36. Any question so far? Macam semua faham ni Dr. Isma.
Dah. Kalau tak ada soalan tu, maknanya dia faham lah tu.
Okay, no question? Okay, if no more question with that, we have come to the end of today's Slope W workshop. On behalf of all the lecturers, I would like to express my sincere appreciation and thank you to our speaker, Professor Madya Dr. Isma Jayadi, for his valuable time, insightful sharing and also guidance throughout these sessions. Also, I would like to thank all the participants, all the students for the participation and also cooperation. And I hope that this session has provided you clarification and also helpful in completing your assignment effectively, okay? I think that's all for me. Thank you so much, Dr. Isma, and also all lecturers here.
All right.
And also
You're welcome.
students. Okay, thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.